Hey, what's up, class? Welcome back to another episode of Math 1 Distance Learning. Hope you guys are doing well. Today, we're going to be talking about intercepts, the x-intercept and the y-intercept. We're going to learn a couple of ways to identify those when we're looking at a function or a linear equation. And then we're going to use those to do what I call a quick graph. We're going to graph the function, but instead of doing calculations chart, we're going to do a quick graph by using those intercepts. So you should have the notes in front of you called quick graphs using intercepts. So let's go ahead and get started. And all right, here we go. I'm going to flip over to the DocuCam. All right, quick graphs using intercepts. Okay. So our objective is we want to be able to graph a linear equation. So graph linear equations by identifying the intercepts of the graph. Okay, so we're going to be working with linear equations. That's what we've been working with this entire school year so far. And we want to be able to identify what we call the intercepts. All right, so let's do a quick review here. Let me adjust this camera just a tad, bring that up. All right, so a quick review. So a linear equation, when we're talking about a linear equation, it's an equation. Remember, it has an input, so it's got an x value or an x variable, and it also has an output. So it's got an input and an output, and that's usually our y variable. And when we graph it, it makes a straight line, right, when graphed. Now, you have an updated version of these notes on yours. I just want to make sure we remember a linear equation is a function. So when we're talking about a linear equation, we're talking about a function. It's got an input and an output. So it is a function. And when it's graphed, it makes a straight line. All right. So linear equations, they usually come in two formats. And on your notes, I think you've got Optimus Prime over here. I added him. So remember, like a transformer, like Optimus Prime, he can be a robot, or he can transform himself into an 18-wheeler semi-truck, but it's still Optimus Prime. So it's the same with linear equations. They can be in this format, what we call slope-intercept form, or they can also transform into standard form. And so let me give you an example here. So slope-intercept form is y is equal to mx plus b. And so we'll plug in some numbers. I'll give you an example in a moment. Over here for standard form, we've got some different letters, but we still have an x and we still have a y, right? So here's our x and here's our y. And then we've got a couple of different letters. This has a C, this does not, obviously. This has an A, and this one does not. Okay, so let me show you a slope-intercept form. We've been working with these. And this is what we would traditionally, this is how we would write functions. We would put an f of x right here. This is our slope right here. We have our input variable, and then we have, this is actually the y-intercept. We'll learn about that. But we've got y is equal to mx, and then this could be a positive or a negative. Now, I'm going to take this equation right here, and I'm going to transform it into this format, and it's going to actually look different. This has a fraction. Over here, there's no fraction. But this is actually the same equation. They're both the same equation. If I was to graph this, and I was going to go graph this one, they would come out, they would be the same graph. They're the same equation, just transformed into two different formats. Just like Optimus Prime can transform from an 18-wheeler into a robot, and from a robot back into an 18-wheeler. Okay, all right, so slope-intercept form and standard form. And we're going to learn how to find the intercepts. That's what we're talking about. We're going to learn how to find the intercepts using this format, and we'll also learn how to do it in this format. So it's not too difficult. So let's review really quickly. Let's graph using a calculations chart. So remember, a slope-intercept form, it's like an input-output where we can graph equations by calculating points. So we want to calculate points or ordered pairs. Okay, so let's go ahead and use a calculations chart for this function right here. So we're going to graph the function f of x. We're going to change that to a y. So I'm going to come down here and set up my chart. And so here's my 2x minus 4. Here's my 2x minus 4. Now, hopefully, by this point in the school year, you remember that if they don't tell you what to plug in, there are 5 numbers that we typically want to use. And those 5 numbers are right there. Okay, so we typically want to use -2, -1, 0, 1, and 2. I'm going to take those and we're going to go plug them in. We're going to drop it like it's hot, one at a time. So let's go ahead and take -2 and drop that in. So we got 2 times -2 minus 4. So that gives me -4 minus 4. So that's a -4. And another -4 is going to give me -8. And so the dance partner is -2, -8. So those are dancing together. So let's go ahead and do the same thing with -1. I'm going to go 2 times -1. So that's going to give me a -2 minus 4. And that's going to give me a -6 right there. So -2 and then another -4. So -2, -4 is -6. And we get -1, -6. Now, we've started talking in class about patterns. So if you notice, this went from -8 to -6. Let's see what the next one goes to. The next one, we plug in a 0. That's going to be 0 minus 4. That's a -4 with a point at 0, -4. And so now, hopefully, we can see the pattern. So I went from -8 to -6 to -4. So the next one should be -2. And then the last one should be at 0. Okay. All right. Now let's go ahead and graph those. Just to point out, so that is a rate. It's changing by 2. And we've talked about there's your rate right there. And we also call that the slope, right? So there's your rate. This is changing by 2. And the reason it's changing by 2 is because we're multiplying by 2, by 2, by 2, by 2. Okay, so let's go now and take these points and let's go ahead and graph those. So remember, we start with our X. These are like dance partners. The guy leads, and then we go find his dance partner. So we're going to go -2, -8. So -2, and then down to 8. And then the next one is -1, -6. So -1, -6. Now, we could actually just use the slope or the rate. It's up 2 over 1, up 2 over 1, up 2 over 1. And that puts us at 2, 0. So I have these 5 points. So I'm going to go ahead and take my ruler and I'm going to draw my line. That's a positive slope, right? That's going up. Okay. So this is kind of the old school way of graphing. So we just graphed this function, but it took us a while. It takes a while to come up and to generate all these points. So the purpose of this lesson today is to be able to graph a function like this, but to do it much quicker, to use what we call the intercepts. All right, so let's go on to page 2 and let's talk about what these intercepts are. So let me get my little cover here. All right, so an x-intercept is the location, or what we call the point, the x comma y, where the graph, which is the line, the graph crosses the x-axis. It's the intersection point or collision point. Okay, so it's where it's crossing. It's crossing the x-axis. We call that the x-intercept. If we were to look at our picture really quickly here, so this graph is crossing the x-axis. Here's our x-axis. It's crossing right there. That would be our x-intercept. That's where it's intersecting or colliding with our x-axis right there. Okay. All right. So the x-intercept is crossing the x-axis. All right. And then you could probably figure out the next one. The y-intercept is the point where the graph crosses the y-axis. So once again, if we were to look at our picture here, our graph, here's our x-intercept, and then here's the y-axis right here. and that's crossing at that location right there. So that'd be our y-intercept. Okay. All right. So if you know the intercepts, then it's really easy to graph. If you know those, we're looking for that intersection point. So here, draw a graph with a y-intercept of -2 and an x-intercept of 5. Okay, so we know it's going to cross the x-axis, right? The x-intercept's crossing the x-axis at 5 and the y-axis at -2. So let's go and do that. You're going to need to draw in some little unit marks on your graph. And so the x-intercept is at 5. So 1, 2, 3, 4, 5. That's your x-intercept. So go ahead and label that x-intercept 5, 0. And then your y-intercept is at -2. And that's down 2 right there. And that's your y-intercept at 0, 2. Now, we've already done one lesson in class where we talked about these intercepts. So I gave you kind of a prequel, like a little preview lesson. And one of the things that we talked about in that lesson is, what do intercepts have in common? Hopefully you remember what they have in common is whether it's the y-intercept or the x, they have a 0 in their values. There's a 0 and there is a 0. Okay. All right, let's try another one. Draw and graph a function with an x-intercept at 4, 0 and a y-intercept at 0, 6. So up here, I just gave you the one number and that one number, but now I'm actually giving you the actual point. So 4, 0 and 0, 6. So let's go ahead and do that. And this one is going to look a little differently. So 4, 0, 1, 2, 3, 4, put a point. Make sure you are putting your marks if you want to get full credit for this assignment. And then the y-intercept is at 0, 6, and that's 1, 2, 3, 4, 5, 6 up there. Okay, now let's just talk really quickly. Let's just slow down for a moment and let's just look at the two graphs. This graph right here, right there, is this going in a positive slope, a negative slope, a 0, or an undefined? What would we say? Think about that. That is a positive slope, right? It's going up, like positive people take you up. We read graphs from the left going here. And so that, if we read that graph from left to right, it's going up. It's in a positive direction. This one here is in a negative direction, right? It's going down in a negative direction. If we were to start here, we would roll a bowling ball down the hill, right? So intercept and an intercept. Here's an intercept and here's an intercept. So notice if the slope is a negative slope, then my y-intercept is going to be up here. But if it's a positive slope, then it's likely that my intercept will be down here. Now, we could have a line that's like this up here, and then we would have that up there. So that's possible, okay? All right, so at the bottom of these notes here, just kind of a key concept here. So using the x-intercept and the y-intercept as 2 points on the line is an easy way to graph your equation. If you know your intercepts, right, it's an easy way. If you know your intercepts, if you know that your x-intercept is here and your y-intercept is here, all you need are those 2 points. You need those 2 points, and then boom, you can graph your line. Whereas earlier in our lesson today, we did 5. 1, 2, 3, 4, 5. We did 5 values. We don't really need 5 values. All we really need are 2 values. And these are 2 really important. Okay, so if you know your x-intercept and you know your y-intercept, then it's going to be really easy to graph. Okay, so that's part 1. I'm going to come back in just a moment for part 2, and I'm going to show you 2 strategies on how you can find these when you're looking at a function, when you're looking at the actual equation. So for example, if we're looking at this function, I'm going to teach you two really quick strategies so that you don't have to do all of this, but you're going to be able to figure out really quickly where that x-intercept is and that y-intercept. Okay? All right. So um, let's see. So I will be right back in a moment. So I'm just going to break these two videos up. So we've got a part 1, and I'll come back in just a moment for a part 2. All right, so stay tuned. We'll see you in just a moment.